Hello students, I would like to say welcome to all of you in this Misostudy video class. So once again I hope the topic is clear to all of you what exactly we are planning to discuss. That is in this particular chapter, the name is Electrostatic Potential and Capacitance. We completed this chapter, the theoretical aspects long back. So now I thought it's best time to start the discussion of the questions. Only by means of these questions you can brush up your basics, your conceptual clarity. Fine. So this is not like that only one or two exercise. Fine. It is going to be a continuation process, one by one, next, and so on so forth. Fine. But definitely, as you know, in Misostudy we only emphasize on quality, not quantity. So what we will do, we will pick up good questions, I will elaborate those questions, and by that we will try to ensure our best understanding of the concepts. So here let's start this discussion. And one more important thing, I hope you all are now aware with that, the solution of these questions are also present in your ebook. Fine. So whatever I am explaining in the video is something which is essential parts only. It's not like that I am providing step by step entire solution. So if you want to take the look of the detailed solution, although it is not required, the way I am going to explain, things are going to be very clear. But still, if you want to take a look of that, you can take a look of your this ebook. Fine. So here let's start this discussion of electrostatic potential and capacitance topic and some good questions from JEE main pattern exam. Okay. Here it's your first question. The capacity of an earthed spherical conductor is how much? It's a very tricky question. No formula, nothing. Very simple and tricky. Tricky in the sense, there is one specific term mentioned over here, that is earthed. And the symbol of earthing in any type of circuit is like this way. Let's say for example, this is a capacitor, say for example. And earthing means the symbol is like this. Fine. And as you know, earth is infinite reservoir. You may take out infinite amount of charge and you can provide infinite amount of charge to the earth. Okay. So earthed spherical conductor. Fine. So what we will do, we will first try to draw this simple diagram. Let's say in general the conductor is spherical in nature. Okay. And wherever it is connected, let it be like that, but earthing is given in this fashion. Fine. So this is now earthed spherical conductor. So what about its capacity? Capacity means capacitance. C means ability to retain charge. What is the basic formula that we are supposed to use? That is Q is equal to CV. Fine. So from here what we can say, C is equal to Q by V. Okay. Now we will try to find out how exactly you are going to get the value of this capacitance. Now you can provide any amount of charge to this conductor, not a problem. But because of this earthing phenomena, what will happen? This V is going to be 0. And if V is going to be 0, then something upon 0 is you know what. So let me give you the simple solution of this particular problem. In any condition V is equal to 0. So therefore C is equal to Q upon 0, and that will give you C is equal to infinity. So the correct answer is this one. just because of the earthing, whatever is the charge, basically potential is 0. That is the simple logic behind this question. Now, in JEE Mains and JEE Advanced exam, these type of questions are very common. Common in the sense 1, 2, 3, I mean like nearly 1 or 2 questions till 3 number of questions. You may get these type of questions from different topics. They are very simple, and I should use the word crispy questions. If you are slightly confused, then you are going to get the wrong answer. So that's why I am starting this entire discussion with the help of this very first question, just to give you the different feeling or approach. Fine. As such, this is not difficult, but at least basic conceptual clarity must be in your mind, and that is, what is the method of earthing, what are the aspects of earthing, why earthing is necessary. So all these things are quite essential. Fine. Then comes this question. The capacitance of a spherical conductor depends upon what? These are certain options given to you. So what I will do, let me allow to draw a simple diagram over here. Fine. And then one by one I will explain you what exactly has been asked in the question and what is the correct solution. So for the time being, if some portions are not visible to you, don't worry. It is like that, this is a conductor. Fine. So problem is, at what parameters this capacitance depends, this capacity of this conductor depends. Okay. So Q is equal to CV is a correct formula. Fine. And C is equal to Q by V. Just 2 minutes back we completed this discussion. Okay. Now we have to find out at what values, I mean these parameters, C depends. So first hand you can say charge and potential on both capacitance depends. Remaining I will let you know. So first is electric charge stored on the conductor only. Fine. So capacitance depends upon electric charge only? No, it depends on voltage also. So this first option, it don't seems it's a correct option. Okay. Electric charge stored and potential through which it is raised. Fine. Now this may create some sort of confusion. Electric charge and potential, both terms are clear. So is it like that? Wait. Fine. This put in you can say suspect, in the category of suspect. Correct answer. Fine. Then is shape, size of conductor and medium in which it is placed. Okay, shape, size and medium also, it seems, it may be. Fine. Only shape of the conductor, no. So A and D outrightly rejected. This is basically the method that you should follow in examination hall. Why? Because this is known as the intelligent elimination. So now in next reading you need not to read option number A and option number D. So now you have only 2 options. So this is something which is known as elimination process. Fine. So now we will try to focus our attention only on for B and C. So let me allow to write down over here. V is equal to 1 upon 4 pi epsilon naught Q upon R. Why I delayed the presentation of these questions based upon capacitance and this electrostatic potential? Reason is simple. After completing all those chapters, now if I am anything writing, you may easily understand what I am writing. So that is the main point of delayed presentation of these questions. Fine, I not presented this question just after finishing the chapter. So this is potential 1 upon 4 pi epsilon naught Q upon R, a well known formula. Okay. So from here, as C is equal to Q by V. Fine. So place the value of B from equation number 1 in equation number 2. Okay. So therefore C is equal to Q, this Q upon Q into 4 pi epsilon naught R. I hope you all are comfortable with this expression. One thing that you can add more over here, that is, this is epsilon naught, permittivity of free space, and one more term, that is epsilon R, permittivity of medium, relative permittivity, that is known as. So now this Q and Q going to be cancelled. So C not depends upon Q and V only, but C depends upon size and shape of the conductor and relative permittivity, or you can say in simple terms, on the medium. Fine. So now if you talk about electric charge stored and potential through which it is raised, then it is not like that C depends only upon Q and V, but C also depends upon radius, means the size, also depends upon relative permittivity. Fine. So that's why option B is not correct one, shape, size and medium in which it is placed. So this one is the correct answer. Fine. C is the correct answer. And these questions in capacitance and this potential, it's a very important topic, very good topic also. Fine. Initially I am discussing very simple questions, so that you can start a liking in your mind about the numericals in physics, because general complaint of the students is what? Physics is simple, we can understand, but we can't solve the problems. Numericals, oh my god, that's very difficult. So that's why I am starting the discussion with the very simple questions. A 40 microfarad capacitor in a defibrillator is charged to 3000 volt. The energy stored in the capacitor is sent through the patient during a pulse of duration 2 milliseconds. The power delivered to the patient is how much? Now what exactly this question is? One, this defibrillator, then patient, and then what exactly? Let me explain you. As you know, students, in medical science, maximum instruments are made using the concepts in physics, whether it is X-ray, whether it is MRI, CT scan and so on and so forth. Fine. So now this device, defibrillator, it is used to you can say provide some sort of shocks to the heart, so that it starts pulsing, these pulses. Fine. Pulses should start come out from that natural pump which is responsible for pumping blood in our entire body. So now this is a device, and this device works on the principle of energy stored in the capacitors, and then as and when required it utilizes that. So you have to find out the power delivered to the patient in 2 milliseconds. Fine. How exactly we can find out? If you have regularly watching these videos of theory, then very easily you can understand one thing, which is something I mentioned over here, that energy stored in a capacitor is half CV square, this type of relation. Fine. So let me allow to write down few terms over here. At least I can write down U is equal to 180 Joule. Many of you may think from where we are getting this formula. So simple, we are getting this formula from the relation, that is, I am going to write down over here, it is half CV square, or I think I should write it over here only with different color chalk, that is U is equal to half CV square. Values are given, fine, C given, V given, you just put the values, and this number is your first outcome. Then what exactly this outcome is going to be used? So U is equal to 180 Joule, and what is required? Power. Power delivered power delivered to the patient. Power delivered to the patient in 2 milliseconds is, power delivered to the patient in 2 milliseconds is P is equal to 180, this value of energy, divided by 2 into 10 to the power minus 3. So easily you can say this 90 kilowatt is the power, that is 90 kilowatt. Fine. So as such, question is not difficult, only you applied and conservation of energy phenomena and then you are getting the correct answer. Fine. As such, you should not think like this, why the teacher is picking some very simple problems. Reason is, I know it's not possible for each and every student to remain in touch of these subjects. Fine. So for that reason, few of you may feel, okay, this relation, so simple relation, but at least you should try to move ahead with the help of these simple problems. Fine. Big question, but try to understand. A fully charged capacitor has a capacitance C. Okay, it is discharged through a small coil. Coil means resistance, embedded in a thermally insulated block of specific heat capacity S and mass M. Fine. Let me allow to draw the diagram. So a fully charged capacitor has capacitance A. It is discharged through a small coil embedded in a thermally insulated block of specific heat capacity S and mass M. Okay. This is, let's say, this block. Fine. And inside this block, this entire arrangement is placed. Okay. If the temperature of the block is raised by delta T, fine, the potential difference V across the capacitance is how much? I hope the problem is clear to all of you. Otherwise, let me allow to show you. Let's say this is one solid block and inside that you are arranging this entire experiment. Then what exactly the, you can say, expression for potential difference in this condition? That is very simple. So let's start discussing. And in these type of questions, students, really some amount of practice, very minute amount of practice is essential. Nothing else, nothing more. Fine. So here half CV square, fine, half CV square is equal to MS delta T, our well known relation. Fine, class 11 thermodynamics relation. So you have to find the value of V. If the temperature of the block is raised by delta T, the potential difference V across the capacitors is how much? Fine. So we are talking in terms of potential. So V is equal to 2 ms delta T upon C, and that too with under root. So 2 ms delta T upon C is the correct option, and from here if you will just check, so B is your correct option. I think ms delta T, yes, finally you can use this value, which is going to be how much? That is capital T. So as such, these questions are not difficult anyway, but yes, some sort of thinking is required, and by means of practice I hope you can achieve this perfection. Now at some point of time, if some steps are very simple in any question, then definitely I will not explain them. Simply I will pick up that result and will use that. Here it is, question number 5. The capacitance of two oppositely charged metal spheres, each of capacitance capital C and of same radius, when placed far apart, will have to be equal to how much? Fine. You can say this question is based upon the interaction. Fine. That is capacitance of two oppositely charged metal spheres. So, two spheres and the interaction. Fine. So, what should be the approach for this problem? You know, in a capacitor there are two plates. One is with positive charge, with negative charge. Okay. Now, what exactly the situation? What exactly the solution? So, the solution is V plus. Why I am writing V plus? Because you all are aware that in a this particular capacitor there are two terminals. Fine, two plates. So, V plus is equal to 1 upon 4 pi, V plus is equal to 1 upon 4 pi epsilon naught into Q by R. Sorry. Then next is V minus. Fine. So, V plus is this much and V minus is with minus sign only. Fine. So, this is one way of QR. Yes, QR. So, what is the net potential? So, dW, that is V plus minus V minus. Fine, V plus minus V minus. So, ultimately it will give you 2, not 2V. Fine, we will try to solve it, and how we are going to solve it. So, when we will try to solve it, finally what we will get? We will get 2 pi epsilon naught R. Fine, yes, correct it is. Simply by putting the values you can write down this equation. Now, this upper portion I would like to remove, because I have to explain something important over here. And what is that? That is C prime, that is new capacitance. So, C prime is equal to Q by dV. Fine, Q is equal to Q upon dV. And here if you place the values by putting values, okay, and solving, I should write down, and solving, fine. By putting values and solving, then C prime is equal to C by 2. So, B is the correct answer of this particular question, which is slightly, you can say, long in just terms of reading or so. And now we will go for the discussion of next question. If K is the dielectric constant of a medium and epsilon naught is the permittivity of free space, then the energy stored per unit volume of the medium is given by, directly formula based question. So, as such no explanation is required over here, and this formula based question will say that 6C half K epsilon naught E square is the you can say the value of this particular expression. Fine. So, here energy is basically saved by this dielectric constant. Fine. So, the energy stored per unit volume of the medium is given by which expression? So, the expression 6C is in front of you. Okay. So, this question is just I placed over here because this year's JEE mains exam pattern, there were few questions in physics, they were directly formula based question. So at that point of time I decided that now onwards I'll have to do these things. Fine. A capacitor of capacitance C is fully charged by 200 volt supply. Okay. It is then discharged through a small coil of resistance wire embedded in a thermally insulated block of specific heat 2.5 into 10 to the power 2 kilogram and of mass 0.1 kg. If the temperature of the block rises by 0.40, if the temperature of the block rises by this amount, what is the value of this C, capacitance? Okay, slightly long question and some sort of, you can say, solution too. But let me allow to solve this particular question. A well-known formula in half mv square that is associated with the kinetic energy. So similarly, on the basis of this, you can simply write down half CV square. Whenever you are solving problems like this, then what you should do, your approach should be like how much? Your approach should be write down formula. Let's say for example I am writing half CV square. In the meantime I am saying half mv square is the kinetic energy of the moving particle. So it's like that we are learning how to correlate these things. Anyway, half CV square is equal to, so what I'll say over here, after solving. Fine. So half CV square, you put the value, and after solving, what the value you will get, that is 2 into 10 to the power 4 C joule. C is something which we have to find out. Okay. The calculation is very simple, that's why I not in a process of calculating the values. Ultimately important is concept. Now over here, energy appearing as heat, energy appearing as heat is ms. Fine. So now easily you can solve it. The value of 10 into half CV square you can get from here. You can put the values and accordingly you can solve. Basically you are supposed to get over here half CV square, which I am directly writing as a value. So this C value is 500 micro, this capacitance, and obviously ms delta theta 200.1 kg, 500 microfarad. It's correct because it is 2 into 10 to the power 4. So no problem at any point of time, it's quite correct. Till now I am sure you must have noticed that I not tried to explain you a very complicated question. There is no point. You should prepare your strategy long before the exam, and that strategy must be not exactly foolproof, but at least. So strategy is also very important over here. This ratio between the energy stored in 5 microfarad capacitor to the 4 microfarad capacitor in the given circuit. Fine. What exactly the process is? Let's say name of this point is A, name of this point is B. Fine. So accordingly we have to decide. First we have to summarize and nullify the circuit. So first I am going to do, and one more thing that I would like to mention over here to all of you, that the revision of these problems utmost important. Fine. So I net, that is net current flowing. Fine. Why I am doing this? Just wait for some time. Once I will explain net current, then we will jump for the understanding of this sudden appearing of this net current. Okay, I net means complete current, total. So I net is equal to 2 by 10 is equal to 0.2 ampere. Fine. Now what will happen about the voltage drop as per this current equation? So voltage drop, fine, voltage drop across, now consider the situation, voltage drop across the capacitor, across the capacitor, across the capacitor. I net is this much, V drop across the capacitor is how much? It is 1.2 volt. I already calculated, that's why I am not wasting your time over here in this video. If the detailed solution which I provided is ready with this particular topic, then it's very good. So voltage drop across the capacitor is equal to 1.2 volt. Fine. So from here what I can write down, 1 by 2 into 5 into 10 to the power this micro, so minus 6, this value. Fine. So 5 into 10 to the power minus 6. Now solve it. Okay, and similarly you will get E2 is equal to half into 4 into 10 to the power minus 6, and then this value of half this CV square. So yes, 1.2 whole square. Similarly a multiplication of 1.2 whole square. So this is the value of E1 and E2. And then if I am interested to find out the ratio of E1 and E2, then it is E1 fine, E2. So 1.25 is the correct answer. As such, there is no unit required because it is the ratio of same two quantities. .25 is the correct option after putting the values in the given equation. Here comes your question number 10. 3 plates of common surface area A are connected as shown. Fine. This way 1, 2, 3. The effective capacitance will be how much? This question is less calculation required, but conceptual understanding is must. That is, actually this is the problem. Now you can imagine this entire setup for the understanding of these concepts, that which one is correct. Now as I mentioned formulae many times, so now in this question I will not explain those formulae. Fine. So what is your correct answer? Fine, this is your correct answer. So this is what? This is simplified circuit. Fine, this is simplified circuit. Now gradually we are moving towards our final question. 4 metallic plates, each with a surface area of 1 meter. One side A are placed at a distance d from each other as given in the figure. The capacitance of system between A and B. Okay, so you have to find out the value of the capacitance difference between A and B, capital A and capital B. Fine. Simplified version of the situation A, B. Let's say like this. Fine. So there are 2 points as I mentioned over here. So finally what we will do, we will write down the formula directly. And what is that direct formula? CAB is equal to 1 upon C. Fine. And then from here AB is equal to what you can say? You can say epsilon naught A by 2D. Fine. And then CAB. Fine. And this CAB will give you between these two bigger terminals as 3 by 2 epsilon naught A by B, where symbols have their usual meaning. So this question is slightly long, but if you just start visualizing, it's going to be very simple one. Let me allow to visualize you once this question. What exactly they are asking? Fine. So they are basically trying to find out how exactly you can decide by taking a look of this type of arrangement of plates, how you can decide how many these capacitors are present. Fine. Something you have to take common, and because of that reason the situation is like this. So students, what I'll do, I'll try to stop over here. Why I am saying I will try? Yes, it is required also. Stop over here, and very soon we will be coming back with new set of questions. Fine. So till then, take care of yourself, keep revising, have a nice time.